follow-up video on this. And we're going to take a look at y equals sine of x. There's 4 points that you need to know. Well, really 5. You need to know 0, pi over 2, which is 90, pi, which is 180, 3 pi over 2, which is 270, and 2 pi. If you know those, you'll be in good shape. And it only fluctuates between 1 and negative 1. And here's the deal. Sine will just go like this. Ooh, I have one extra dot. Oh no. And it looks something like this. And it goes on forever. Now, cosine starts here, and it follows a very, very similar path. Tangent, however, has asymptotes, and tangent is a little bit weird. And I'm going to do a much better job in a minute, but you'll see. There's going to be a couple asymptotes, and the tangent function looks like this. It goes, and then up like this, and then up like this. Now you might be thinking, oh my gosh, well that doesn't help. So I'm going to show you what I can do. On Desmos, what you can do is you can actually put in, I typed in, you might not believe this, but I actually typed in, I'm going to show you, on the x-axis, -2, and then I typed in the words pi, and that actually comes up here for the step, and then here I did 2 pi, and that came up. I'm going to do my axis between -2 and 2, and I said I want my step to be 0.25, which is 1/4. Here I said I want my step to be pi over 4. And now I'm going to show you what this looks like. If we were to graph y equals sine of x, you can see at pi over 2, we're up here at 1. At pi, we're at 0. 3 pi over 2, we're at -1. And then 2 pi, we're there. So that's one full oscillation. All right. If you throw a number in front, like 2, it doubles the amplitude. It's called the number in front of the sign of the trig function is called the amplitude. It tells you how big your sine curve is going to be. And then we can actually do something else. I'm going to put this back over here. If I type in 3, you'll see it then changes how frequent it happens. This is the coefficient of x is the frequency. Now, there's something else about the frequency. So this happens twice. You'll see it starts here, goes to here, then to here, then to here. And at pi, it completes one oscillation. When it goes all the way to 2 pi, it completes a second oscillation. So the point is, the coefficient of x tells you how many oscillations or how frequent it will happen over a period of 2 pi. Now, if you want to know how long it will take to do one full oscillation, what you have to do is you have to take 2 pi and divide it by the coefficient of x. So 2 pi divided by 2 is pi. And that's why you can see, starts here, goes up, down, and finishes at pi. Well, here, I'm going to do the cosine function. Well, first I'm going to do regular cosine. You can see once again, this starts at 1, goes down to 0, -1, up to 0, and then finishes at 2 pi. That's one full oscillation. But if I do it over 2, what happens is, remember I said take 2 pi and divide it by the coefficient. Well, here the coefficient is really 1/2. So 2 pi divided by 1/2 is really 4 pi. So here goes, that's half of 1, and we're only at 2 pi. And then up to here is 1 full oscillation, and that's 4 pi. And then finally, here's y equals the tangent of x. You can see all of the asymptotes, and it happens at pi over 2, negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. So I think you can pretty much figure out that's 1 pi over 2, 3 pi over 2, 5 pi over 2 should happen at 7 pi over 2. Oh, here's 7 pi over 2. I was going to say, oh, I'm really confused. There it is, 7 pi over 2. So k pi over 2, where k is an odd number. That's it. I hope this helps, and I will see you when I see you.